So today's class we are going to study the design of Butterworth filter using bilinear transformation method. So here the given problem is we have 0.0707 less than or equal to modulus of h of e power j omega less than or equal to 1 for omega varies between 0 to pi by 2 and modulus of h of e power j omega less than or equal to 0.2 for 3 pi by 4 less than or equal to omega less than or equal to pi. So this is the given problem. So in this the given datas are the gain A1, A2 which is A1 is 0.707, A2 is 0.2 and the frequencies are omega 1 is pi by 2, omega 2 is 3 pi by 4. With these four datas we have to undergo the design procedure. So first we have to determine the analog edge frequencies which is given by the formula omega 2 by omega 1 equal to tan omega by 2 divided by tan omega 1 by 2. So in the place of omega 2 we will be substituting 3 pi by 4. In the place of omega 1 we will be substituting pi by 2. So after substituting these values we will be getting the value as 2.414. So we have to calculate this. You have to keep your calculator in radian mode and perform the calculation. The next step is you have to determine the order of the filter. So to determine the order of the filter, n is equal to 1 by 2 of log of 1 by a2 squared minus 1 divided by 1 by a1 squared minus 1 divide the whole thing divided by log of omega 2 by omega 1. So in this, if you substitute the value for a1 and a2 and omega 2 by omega 1 in previous steps already we have found 2.414. When you substitute these values here, you will be getting the answer as 1.8 which is we have to approximately equivalent to rounding off to 2. Then we have the next step is we have to determine the analog cutoff frequency omega c which is given by the formula 2 by t of tan omega 1 by 2 of 1 divided by 1 by a1 square minus 1 whole power 1 by 2n. So we already know omega 1 value and n value we obtained as 2 in the previous steps. A1 value also it is given in the problem. After substituting these values you will be getting the omega c as 1.99. Then the fourth step is you have to determine the analog transfer function h of s. Since the n is equal to 2 which is even numbered, there are two different transfer functions, one for even number, another for odd number. We have to choose the even number. So here h of s equal to the product, this symbol represents the product of k equal to 1 to n by 2 bk omega c squared divided by s square plus bk omega cs plus ck omega c squared. So omega c we have found it as 1.99. We'll be substituting here and then to find out the b1 substitute, if you substitute the k equal to 1, this is the expression you will get. So in that b1 equal to 1, c1 equal to 1 and small b1 we have the formula. So in the small, to find out small b1 the formula is 2 into sine of 2k minus 1 of pi divided by 2n. So in that if you see substitute the value of k as 1 and n equal to 2, we will be getting the b1 as 1.414. Now in this equations we have the value for b1 as 1, small b1 as 1, c1 equal to 1, small b1 is 1.414. So omega c is 1.99. After substituting all these values, we will be getting the transfer function as simplified transfer function as 3.9601 divided by s square plus 2.81s plus 3.9601. So now in this equation, if you have to apply the bilinear transformation method, we have to replace s by 2 by t of z minus 1 by z plus 1 and the t value we can assume it as 1 second. So if you substitute the s as 2 of z minus 1 by z plus 1, here s square, so it will be squared whole square plus 2.81 into s is 2 into z minus 1 by z plus 1 plus 3.9601. In this you have to simplify it further. So here 2 of z minus 1, when you square it, 2 square it is 4, z minus 1 the whole square divided by z plus 1 square plus 2.81 into 2 is 5.64 into z minus 1 by z plus 1 plus 3.9601. Then again in the denominator we will be taking the LCM of it. So when you take the LCM it is z plus 1 whole squared. So it is 4 into z minus 1 whole squared plus 5.64 into z minus 1 by z plus 1 plus 3.9601 into z plus 1 whole square divided by z plus 1 whole square. this z plus 1 whole square will be going to the numerator, then it is divided by this term. So in the denominator term, when you multiply and simplify this further, you will be getting the expression as 0.2911 z square plus 2z plus 1 divided by z square minus 0.58z plus 0.1705. In this numerator and denominator, you can divide by z square. If you divide the numerator and denominator by z square, in the numerator you will be having 0.2911 of 1 plus 2 into z by z square, it is 2 z inverse, plus 1 by z square, it is z power minus 2, divided by, in this denominator when you divide by z square, it is 1 minus 0.58 z inverse plus 0.1705 z power minus 2. So this is the final answer, you will be getting it. Thank you.